Welcome to today's webinar. We want to say thank you so much for attending. Today's webinar is Tankful Strategies, Navigating Custody Transfer, Overflow, and Compliance with Precision Tank Monitoring. With your presenters, Joe Bourgeois and Angel Galvan. Joe, the floor is yours and you can get started.
Hey, thanks, Mike. Hello, everybody. Joe Bourgeois, I'm the Vice President of Engineering Innovation here at Relevant Industrial. And we also have Angel Galvan, who's one of our project control leaders. And we are very happy today to come to you and discuss a topic that we've seen quite a bit of activity in over the last number of years, and that's around tank monitoring. And we've run into a number of lessons learned that we thought we would share with you all. So welcome today, and hopefully we can answer some questions for you and give you a bit of a perception of tank monitoring that maybe you haven't considered before, and things to think about as you're looking at your own projects in the future. Real quick about Relevant. Relevant is a world-class distribution company, but it's unique in that we have some specific domain expertise that most people do not have. We have domain expertise around measurement and instrumentation. We have domain expertise around control systems from PLCs to SCADA to DCSs, specific domain expertise around combustion burner management, rotating mechanical equipment, filtration, and wireless solutions, just to name a few. And we combine that with a full system integrator capability to execute and project manage projects for our customers. So a little bit different than your normal distribution partner in that we also have the domain expertise and system integration and project management capability to help you not only find the right technology, but execute your projects with excellence. In this case, we want to talk today about accurate tank monitoring and what are some things you might consider when you do that, and then give you an example of a large project that we're still working on, but we've completed 70 to 80% of the project, and wanted to share that with you. Again, our lessons learned and some things that you might consider when you're looking at your tank monitoring solution. So why do we need accurate tank monitoring? Different people need it for different things. In our case study, it's actually more around inventory management than anything. Ensuring accurate tracking of your product transfer, making sure you're doing accurate transfer to your customer or internally. You want to make sure you're being cost efficiencies. You're reducing any losses due to overfilling or underfilling, which could also, if you're overfilling in particular, can create safety issues. So you want to prevent hazardous situations due to overfill or leaks. Regulatory compliance. I don't think regulatory compliance is ever going to go down. If you can see the chart to our right of the slide, it shows the spend in labor just in order to meet regulatory compliance, because you get more and more regulatory issues every year, and those are very geographically oriented. So you have to be aware of your local and state regulations as well as your national or international regulations. And then, of course, environmental protection. You want to make sure that you minimize your risk of any spills or leaks. As you're considering your tank monitoring solution, it's more than just putting a measurement device on your tank. There are a lot of different things that you need to consider when you're looking at a tank monitoring solution. You need to look at what's your existing infrastructure. Do I have power available to that, my remote tank farm location, or do I need to use solar or some other kind of battery power capability? Do I have wireless infrastructure or wired infrastructure to bring data back that I may need? And what kind of operations or information data system requirements might I need? What do I need to bring this information to, and for what reasons? And I may have multiple data requirements. And how do I get that from the tank farm back to the house where I need it? What are my environmental conditions? Is it very hot, humid? Your environmental conditions have a bearing on the accuracy and the way that you measure and have anchored tank monitoring solutions. What are the types of tanks you have? Do you have a floating roof? Do you have a solid roof? Is it above ground, below ground? You know, you need to understand what types of tanks you have and what materials are going to be inside those tanks that you need to measure the viscosity and the chemical composition of those materials. And you may need different types of measurement in addition to your level meter. You may need temperature, you may need pressure, flow, you may need to do volume calculations. So there are a lot of things to consider when you're looking at tank monitoring beyond just the level monitoring in and of itself. And we're going to walk you through a case study scenario where we had to include all of these things and the reasons why. So the project, the case study we have, a little bit of background, was actually an international project, and they have 19 oil depots across their entire country. So not only did we monitor a remote, tank monitoring, but we had to do multiple sites in a very dispersed geographical locations around the country of Ghana. All of the tank farms were owned by different companies. So we had to meet all the different requirements in all the different geographical areas, as well as the company requirements for each individual company. And then we needed to get that data back to a centralized data repository to meet the needs for the country of Ghana, to monitor the fuel oil movement around the country and to make sure that they are properly accounting for that custody transfer for tax purposes. And with that being said, I'm going to hand it over to Angel Galvan, who was the principal engineer for the project. And he's going to walk you through the solution and show you how we attack this particular opportunity. Angel?
Thank you, Joe. Well said. So let's jump right into it. Just want to say thank you guys for joining the webinar today. When we take a closer look at Ghana's petroleum network, there's several significant challenges. As you can see, we have leakages, environmental challenges, and infrastructure challenges. And on the right, you have a photo of the country of Ghana, and this gives you a geographical image of what we encountered in this project. As you can see, we have blue tanks to represent where the tank farms were in the country of Ghana. And then also we have the span. So from the top of the country to the bottom of the country, it's about 500-mile span. And then you can see the red arrow, that's where the control room in the crop. So with this being said, the extreme weather was a challenge for us because we needed to make sure that the components were all rated to work in these harsh environments. As far as the remote locations go, we had to be able to communicate all the tank data at all the tank farms through the country of Ghana back to our central control room. And then on top of that, we had the lack of power and wiring at every site. So as you know, we had to run conduit, we had to run power to every single tank in order to power up these gauges, and temperature equipment as well. And also our PLCs that were doing the calculations of the tank inventory system. So we also had to include what we call a power shelter, is what they call it in Ghana. And this included solar panels, battery backups, so that we could have a secure battery resource at each location. And also the road access. So the road access through the country of Ghana was minimal, and it was really hard to navigate to each site to install the tanks, all the radars, and to also disperse the equipment through the country. And so this kind of gives you a general overview of what challenges we faced in the country of Ghana with this project. So all of these challenges were taken into account for our design. And so we'll take you through our design process here in the next slide. So this is what we like to call a complete tankful solution. So we have an end-to-end solution here, from our level gauge on our tank to our control panel in the middle of the screen there to our control room to the right. So what we're going to do, we're going to go from left to right on this on our solution, starting with, okay, the equipment, at each tank. So what we had to do at each site, every location, was conduct a site audit or survey. So basically what we had to do is get tank measurements. We had to know the products of each tank, tank height, basically get the full dimensions of this tank so that we could ensure that we're putting the proper level devices on each tank. Also with that, just making sure that there is no obstructions within the tank to cause any type of measurement deviation from what it should be reading. And so once we gathered all that information, we're then able to generate a bill of materials for every single tank farm. And so once we had that bill of materials, then we could take it back to our engineering team and do a full complete design of our control panel to be able to take the level and temperature measurements all the way back to our control room. So on the left here, you have your tank. And in this case, we use NRAP level gauges. We also had temperature compensation. So in today's world, new regulations, we need at least 1 point of temperature measurement in the tank. And this is to account for any viscosity changes within any type of products, and also to make the accuracy of the level measurement even higher. And so the temperature compensation is a very important deal with this project and any tank farm or refinery that has tanks. Also, you can see we have a local display at the bottom left. This allows for our customers, in this case, to be able to see local data at the tank. We could also bring in other forms of measurement into our level device, such as pressure, or send out alarms whenever a certain level measurement is reached. So with this design, since we had limited to no infrastructure, we're able to utilize Honeywell's ISA 100 network. So with that, we have integrated wireless at every level gauge. So what that means is we can transport our level signal to our control panel in the middle wirelessly. And so we're able to create, I'll show you what that looks like here. If you look at the control room area, you have a tank farm in your top left quadrant, and that is your wireless network. So then we can take all of our data back to our control room there. So what we did, we funneled all of our information to our control panel. As you can see, we have our RTU, or what we call a PLC. So this did a lot of the tank calculations, data monitoring. This allowed us to concentrate the data to send to the control room. We also had to use and utilize wireless 4G cellular communications. So being able to utilize Ghana's wireless infrastructure with the cellular towers allowed us to send all the tank information back to our control room. So as you can see on the right, we have our tanking solution with, well, we had level measurements, we had temperature measurements, and we had volume calculations. Also, since these sites are remote, and to get to one site to the next, it's about 3 to 4 hours. And also from the central location of the control room to the farthest site is around 8 hours. It was very critical that we were able to have remote maintenance and diagnostics at our instruments, because we wanted to ensure that our components within the devices are working properly, and being able to be proactive versus reactive is going to at the end of the day, is going to give us a more safe working environment at our tank farm. So from the end device to our control panel and then to our control room, we had a fully integrated system for every tank farm. And the accuracy was plus or minus 0.4 millimeters, giving us that custody transfer level measurement that we need. We also made sure that we're IoT ready. in this case, meaning cyber secure. So cybersecurity is a big part in today's world. At every industry, every refinery, every site, we need to make sure that our system architecture, our system network is secure. And then we also have had this as the SEAL 2, SEAL 3 rated overflow protection as well. So this kind of gives you an idea of what we had to do. So we just didn't install the gauges on the tanks. We commissioned we programmed the level gauges. We commissioned the level gauges. We sent all that data back to our control room, and we did all the programming and the wireless network. So this was truly a full end-to-end solution for this project. So we took everything into account from the level gauge all the way back to the control room. So thank you, Joe. Next slide.
Sure. Just one question, Angel. Can you talk a little bit about the maintenance and diagnostic software that we had for this solution?
Yeah, absolutely. So what we used was called Field Device Manager. It is a Honeywell's asset management tool that allows us to configure gauges or instruments remotely, and also allows us to read the heart data from each device. The heart data is all the diagnostics to every single component in the instrument. So at any point we have a failure within the device, then we can go back to our Field Device Manager and deep dive into what's the problem and the cause, and then implement that fix to solve the issue. And then so that allows us to have more efficiency in our day-to-day routines at the sites.
Perfect. Thank you, Angel.
Great question.
And the control system, was it a redundant control system? And I believe the control was in 2 separate geographical locations, correct?
Yeah, correct. And as you can see in our control panel here, we have the 2 blue devices with the little antenna. That device there is a cellular modem that sends the data to each control room. So in the country of Ghana, there's 2 control rooms at 2 different locations within the country. And so those 2 cellular devices were sending the tank data to each location simultaneously, giving us a more robust solution, redundancy in the information in the tank level, so that if anything happened to one control room, say such as a disaster or a weather event or a fire or a server crash, we still have the other pair of servers to continue to monitor those levels. And then at the right, bottom right of the screen, you have our historian. So data is the most important and critical piece to this project, is having every single form of data at the hands and fingertips of this company. And so for them, they needed to make sure that at any point they could do their calculations, their reporting, their auditing. And so that PhD, Honeywell PhD, allowed us to do those calculations and give us trending, historization, and any type of KPI analytic dashboards that we need. And also we set up alarms at every tank. So if we got to a maximum safe fill level, the operators will be sent an alarm immediately for some type of action.
And Angel, I would suspect that not everybody needs this level of redundancy, but in this case, because it's customer custody transfer, there's a lot of tax impacts on this data. They wanted to ensure that it was cyber secure, it was redundant, and that the information was accurate, and that they would have an ability to do any kind of preventive maintenance to make sure that the data was consistent and they never lost vision.
Correct. And we tested the failover. So basically we have two clusters of control room servers. And so we were able to actually do failovers. So if one system went down, then they still had visibility to all the tanks at the site. And so with that, they were able to not only just monitor at both sites, but in the form of a disaster, they would never lose communication.
Thanks, Angel. Awesome.
Thank you. So as you can see here, on the right, we have a photo of the actual control room. So we have our customers here, and this is our team, our ground team, a part of them. So we partnered with Honeywell, and they did a great job of helping us do a lot of the implementation and commissioning of the gauges, and also helping us with the through the end-to-end solution. And as you can see, this is what the setup is on the right. And so through this solution, we achieved awesome results. So as you can see, we were able to put precise tank monitoring at every location across the whole country of Ghana. We had end-to-end solution providers, so we did everything from the survey, generating the bill of material, to all the way to the execution of the project and everything in between. And this was a cool fact that we developed Ghana's first electronic metering management system, because before we implemented the system, the way that they were taking the level measurements was through a dipstick. So they'd have somebody walk up the tank and then have a tape where they dropped it down to the bottom, and then have the measurement, and then from that measurement they could have either the measurement or the volume. And so not only did we ensure the accuracy at every tank, but we ensured safety at every site, because now we reduce the amount of times that operators have to walk up and down the tanks, which increases safety over time. And so within the first 10 months of our solution being out and implemented, we're able to save the country of Ghana $86.2 million in tax revenue recognition. And then now, about 3.5 years later, because we've been working on this project since around 2019, now it's been a return more than 1.5 billion. And I think this was the ultimate, end-to-end solution that we provided, from the level gauge to the DCS, the control room. So not only did we help. Yes.
I was just going to talk about the other part that we were very proud of, is we were able to partner with the local communities in Ghana, and this tax revenue was able to improve their roads, hospitals, critical infrastructure. We actually did a computer program of education, helping their education system. So relevant. It's been our pleasure to be a good partner, not just from a business standpoint, but with the communities as well.